Assalamu alaikum. My name is Super Maksud and I am a student of a University Islamabad and I am currently doing mechatronics engineering. So I am here to show you my lab task 11, which in here is lab for FPGA. So first of all, of microcontroller and embedded system lab. So first of all, we had to implement these codes in Quartus. I have downloaded the version Quartus 13. So first of all, I will explain that what is FPGA. So it is same like microcontroller but much more advanced and much more efficient than that. It has many things like 7 segment display, USB port, all everything is installed on it. Is That's why it is very costly. So FPGA is an integrated circuit designed to be configured by a customer designer after manufacturing. Hence, them field programmable. So as I explained in my previous video, they contain an array of programmable logic blocks and hierarchy of configurable interconnects. So as I explained in my previous video, FPGAs are much more advanced than microcontrollers and much more uh, efficient than them. Now I will tell you about Quartus. So basically it is a software produced by Intel uh, to the Intel's acquisition of Altera. The tool was called Altera Quartus Prime. So basically, as we have studied Altera model same, so it is based on that, and we had to do Verilog HDL coding in it. So basically, Quartus Prime enables analysis and synthesis of HDL designs, which enables a developer to compile the designs, perform timing analysis, examine RTL diagrams, which we have also done in our codes, simulate a design's reaction to different stimuli, and configure the target device with the programmer. The Quartus Prime includes an implementation of VHDL and Verilog from hardware description. So basically, we had to do VHDL coding. So basically, Lab 4 was based on multiplexer coding in Verilog HDL. So basically, we should do what is a multiplexer. So multiplexer is a device that allows one or several analog or digital input signals which are to be selected and transmits the input that is selected into a single medium. So basically, it out of many input signals, select any one input and display it on output. So basically it is a kind of a data selector, and data selection criteria vary according to our needs and according to our commands and according to our code. So basically it depends on that. Here we have used 4 to 1 multiplexer, which looks like this. These are 4 inputs and these are 2 controls, and we have to select any one input of the following input depending on our criteria. So basically this was the code. It is implemented through different methods. The first one is gate level implementation. So basically I've implemented this code in my Quartus. As you can see here, this code was implemented. Now I will compile it using control L. So as you can see, it will be successfully compiled. For information, Cyclone 2 is far better than Cyclone 5 because of its speed. It compiles faster than Cyclone 5. That's why we have preferred to use Cyclone 2 and use its architecture EP2C70F89636. So as you can see, it is compiling successfully. So it has been compiled successfully. Now we will going to locate RTL viewer, which will show our simulation. So basically simulation for this code would somehow look like this. So now we will go into new to check its waveform, as it is compulsory university program VWF. So we have to go into insert node bus, node finder, list. Okay, so as you can see, first of all we will check which one is our input and which one is output. So basically if we go into our code, you will see in input 1, input 2, input 3, input 4 and control 1 and 2 are our input. So basically we'll say that control 1, let's suppose we give 160 to it, and 130 to control B. 115. So this is how we will give input to everyone with same time period. Using dividing by 250 and the last one 25. So output we have to display the output. So now I will run this waveform. It has been compiling. This is a simulation flow. So basically, as you can see, these are our waveforms. Let's check our input. Control 1 is our input, and these are all our input, and this is our output waveform, which has been produced because of our code. So basically this was my lab task 1. So for to implement it on hardware, we have to do its pin planning. So basically we have to click on this command, and it will show we have to give input pins here so that we can implement it on FPGA in a hardware form. So basically this was my first task of lab 4, which we call lab 11. So basically for making a new project, we have to select Cyclone 2 here. Then we have to select 4P4C7 4P4C7 as an architecture. For this, in simulation we have to select Multisim Altera. In VHDL we have to select Verilog HDL. We have to click on next, and so this is how our task is made. So basically I will code my task like this. So basically I am compiling my method 3, which is case statement implementation. So we have to now implement multiplexer as case statement implementation, and its code was in here. So as you can see that my code has been successfully compiled. This was my code, as you can see, and now I will show you its pin planner, because we have to implement it on FPGA hardware. So that's why we have to give it input pins here. We have to define its input pins here. Now I will go into locate RTL viewer, so it will show me my simulation of basically code. So basically this is my mux, this is control 1, and this is my output, and these all are my inputs, and this is my output. Now I will show you my waveforms. So I have to do into new and University VWF. So same as before, I have I have given inputs to my inputs. So basically whenever I run this waveform, it is successfully compiling. And now as you can see that these all are my inputs, and this is my output. So my waveform will be like this. So I've implemented these all codes using different methods for mux in Quartus, and using same methods I have generated and waveforms and simulations and its spin planner picture. So thank you so much.